This conference will now be recorded.
So the Docklands Light Railway has been quite a success in East London. It was introduced in the late 1980s, and it's seen many enhancement schemes, whether it's 2 to 3 car capacity or actually extending the route. And there's been many extensions. There's been the Beckton extension, the Lewisham extension. But today, I would like to just tell you a little bit about my involvement with the City Airport extension. It's not going to be perhaps as technically detailed as some of the other presentations we had in the past, but I think hopefully you'll find it quite informative. Okay. Okay, my screen is not advancing. Okay, let's go on now. There we go. So just to give you some top line numbers, and this is specific to the Trackwork side of things. AMXB were the contractor appointed to do the work, and they rewarded the contract. This would have been probably early 2004. The engineering company supporting it were Halgrove. The project value for the Trackwork was around 6 million, and there was 2 areas that this extension revolved around. One was the viaduct that run more or less the whole length of the route, and then there was a number of stations that were going to be newly added to the route. So the site was in Dock Road, which is in Canning Town. So if anyone's familiar with East London, you'll probably recognise some of the landscape there. But this wasn't just purely an office setup, and in that image, in the background, you can see those blue buildings. That was the actual office, but also they had a factory set up on site. And this enabled them to manufacture, obviously, the various concrete products that would be required for this particular project, and the primary one being, obviously, the viaduct. So if we have a look at the civil engineering element, the construction of the viaduct, as I said earlier, the viaduct pieces were made on site, and then they were moved and transported around site using the following methods. So you can see the image on the left-hand side. The viaduct, once the elements were constructed, were left to cure, and once they were fully cured, they could then be assembled. And what was interesting to note was the alignment. So as each segment went along the route, it was aligned specifically to the previous part of the viaduct, therefore ensuring it was an exact fit. The other thing to bear in mind, of course, as well, was services. Now, in the past, you may have seen bridges with services either hanging off the side or fastened to the side. But in this instance, it was decided that the cables and services would actually be within the structure itself. And that image on the right-hand side, you can see some of the cable penetrations actually in situ there. So this is the main entrance to the site. This was the first part of the viaduct as it was coming off the transition slab. And again, you can see the porter cabins there in the background. So the transition slab. So the route come out of Canning Town. So the image on the left where you see the green netting, as the route swung round on that curve, obviously that's your traditional ballasted track, and then it transitioned into the poured concrete slab. And there on the image on the right hand side, you can see there's some timber sleepers, and then ultimately the concrete slab itself. So if we have a look at the track bed, so the precast sections were in place. We now have the viaduct in place. So the civil engineering element has been completed, and now obviously the track work could start. So there was various things to bear in mind, and they're detailed down there on the left. So the client had to make sure the products were available for the installation process. So manufacturing times had to be considered. There was also storage to contend with on site. So all these things went into consideration. What's interesting to note as you look at the image on the right-hand side there, there's some drainage catch bits, if you will, that have been cast into the concrete. So in the event of any heavy rainfall coming down, the rainwater will then drain away to the side of the track and obviously prevent any sort of issues. So for preparing the track bed, a grout pad was going to be used, and you'll see more of that in a while. But to ensure there was an excellent bond between the concrete and the grout, obviously the concrete base had to be scabbled. And this, although quite a manual process, was quite efficient and very effective at what it was designed to do. And if you look at the chap standing at the back there, he has a shroud around, if you like, the footprint of where the grout pad's going to go. And this enabled it to contain the precise locations for these base plates where the grout pads are going to be. So now if we look at the track bed, we now have a scabbled viaduct where the base plates are going to sit. And this is a curve just going out on the first part of the route itself. On the right-hand side of the picture, you can see the other road as well. So this is obviously a twin track. So the next part of the project was obviously to start laying out the component parts. So as you can see here, we've got the track work laid out, and we have the appropriate base plates. And on the right-hand side, that's the same situation using standard 80-pound rail on the Viper base plates. Then the gauge was set up, so obviously it was all aligned correctly, and then the next phase of the construction could begin. For this particular project, for the plain line, the Viper base plate was the base plate of choice. This was specified by Halcro, and as you can see in the image, it's pure and simple, a 2-hole base plate. It also incorporates the fast clip, which obviously makes removal of the base plate should it be needed quite easy to achieve. And the middle image clearly shows you the base plates, so those simply suspended off the rail, how they'll overlie the scabbled concrete for where the grout bed is going to go. So we've now obviously established that the track work was in situ, but a number of things had gone on in the past prior to this, and that was to ensure what anchor or fastening was going to be used. So there was various tests and trials that went on prior to any installation work, and this goes back probably 3, 4, 5 months prior to the track work being constructed. And there was some criteria. The anchors had to achieve 70 kilonewtons, and there was a wide array of different fixings that were going to be tested. It was decided a chemical anchor was the preferred choice, and a male anchor at that, not a female, not a socket. From the initial trials, they were quite wide and varying, if I'm honest, and a number of the chemical anchors actually failed, and it was the bond between the anchor and the concrete that had failed, so it just literally just popped out. As part of those trials, we, as in Hilti, were also involved, and we had 2 chemical anchors that were being tested. One was a resin capsule, and the other one was our injectable resin, our RE500, which is quite unique in itself, and it has a pinkish colour. So from an installation point of view, you can see if our resin has been used, but equally you can see at the top of the anchor, you want to make sure you've got enough resin in the hole. And when this was tested, we found that it was actually the concrete that was failing, not the anchor. And as you can see there, we doubled the loads that were expected with 150 kilonewtons in shear. Now, we was also asked at the same time, what about potential workmanship issues? So as part of this testing, what we also done we drilled out some holes and filled them with standing water. So if the construction work was going on in the winter months, which it was, and there was a sudden downpour and the holes got full with rainwater, what would be the impact of using our resin in this particular scenario? So we drilled a number of 28mm holes. We installed our RE500 resin, and then we placed our M24 anchors. And once the resin had cured, we went back and we tested these, and once again they passed the minimum 70 kilonewton load, and the image on the right gives you an example. So we was fairly confident that this particular resin would be suitable because it's actually used in underwater applications as well. And this was one of the reasons why both the designer and the construction organisation, AMEC, were keen not only to use this, but have some sort of documented evidence to prove the suitability of this anchor. So to supplement the tests we've done on site, we also provided some of our internal test data, and a fair challenge came back. Do you have any external independent test reports? So we had some Transport University Munich reports specifically on our resin and our anchors, and this was overseen by Josef Eiselman. So if anyone is familiar with this chap, I think he's since retired, but he was quite a recognised name within the industry. So that was all submitted, and the anchor part of it was firmed up and confirmed that the Hilti RE500 would indeed be the preferred resin for this particular extension. Now, with any chemical anchor, it's a prerequisite to ensure the holes are clean, dry, and dust-free. And we have an example here showing the image on the right-hand side. The guys are simply just running with an industrial hoover, just clearing out the holes to make sure that they are in tip-top condition. So we've established the anchor that was going to be used, but obviously for the anchor to perform, there was a requirement to drill a hole, and therefore there were some drilling trials. So once again, we got involved with a number of different alternatives, and these range from diamond drilling, rig mounted, we had percussive handheld, and we also had a drilling wagon where you could mount a percussive drill on it as well. The initial interest on the diamond drills was the ability with the base plate you have in the images on the left and the middle. This has the ability to suck itself as a vacuum base plate to the concrete slab. It would also ensure the holes would be perpendicular to the slab, and it was decided, however, that a percussive method would be the preferred choice because, pure and simple, it was quicker. So the drilling wagon was the preferred choice. This enabled a Hilti TE80 percussion drill bit to be mounted on the side. So if you look at the image on the left-hand side, you can see the chap there drilling, and it's used as a pillar drill. So you're not actually holding the drilling machine as such, you're just simply feeding it down. So he's drilling the outer rail, but the carriage that the drilling machine is mounted on can be lifted on and rotated 180 degrees, and therefore enable the inner anchor to be drilled in the forefoot. In the middle picture, this is quite a good example where the guys, you had one team drilling the outer rail and you had another team drilling the inner rail, and they just simply worked along in tandem as they went. And there was a requirement for a 28mm drill bit because the actual anchor rod itself was an M24 hot dip galv grade 8.8 rod. To ensure that the holes weren't over drilled, there was a depth stop attached to the side of the column of the drilling rig. So this had two benefits. Obviously, the first one is you're not going to drill an over deep hole, but also you want to consistently be able to apply the same amount of resin to ensure that the anchor is installed correctly. So yes, obviously prevents over drill, but also ties in with make sure there's not or minimise any resin wastage. What the guys actually done as well on the base plates, they prefabricated a metal block that enabled them to centre the anchor in the middle of the Viper hull. And if anyone, I'm sure you guys are familiar with the Viper base plate, but it's not a hull, it's an elongated hull with a serrated edge, and you have the ability to move the holding down bolt in or out. But they didn't want any damage to the base plate, so the contractor made this metal block that simply sat recessed into the base plate itself and enabled the drilling machine to drill through. So we've established that the drilling machine of choice was percussive, and also off the back of that, it will be rig mounted. The client was also keen to establish, with regard to hand-on vibration, what sort of results could be achieved. So once again, we went down to site. We met up with one of the teams, and we set up our vibration equipment, which was top equipment back in the day, but you'll remember this was 2004. And we done a number of trials over an afternoon, and we got a vibration figure of 7 meters per second. So this gives AMEC the peace of mind knowing the sort of vibration figures that could be expected, and therefore cater with their staff, whether it was rotating it or limiting the exposure to an individual. So, trackwork installation. So we've established how they're going to drill the holes. We know the resin that was going to be used, which was the Hilti RE500 injectable resin. And the rods that was decided was, it wasn't a Hilti product, it was a standard M24 threaded bar. It was threaded top and bottom with a blank section in the middle. So the logic behind this would prevent any wear in the base plate as the traffic passes over the rail if there's any compression. Now, one of the key things with a resin anchor is ensuring that the resin is filled from the bottom of the hole up. So what we had for this particular project and subsequent project is we have a piston plug, which is that plug you see in the middle image. So attached to this will be a length of hose, and the hose would go on the end of the Hilti injectable resin. And as this operator pulls the trigger on the dispenser, the resin is discharged along through into the piston plug, and that plug goes to the bottom of the hole. Now, we were drilling typically 125mm deep embedment. So simply by standing to the side and putting the trigger on the dispenser, the operative can see the piston plug actually advancing towards the top of the hole. So once the piston plug gets to the right depth, you can then obviously stop, remove the piston plug from the hole and the hose, and move it to the next hole. Now that could be a little bit hit and miss. However, on the reverse of the dispenser, and it's difficult to see in this image, so you'll have to just take my word, but on the back of the dispenser on the right-hand side is a dosage meter. So if I go back to the slide I mentioned earlier about drilling a consistent depth of hole, we now have the ability to inject a consistent amount of resin every time for each hole. So this was set accordingly, the piston plug on the end of the nozzle, discharged, and when the dispenser cuts out, the operative knew that the right amount of resin had been injected into the hole, and then he could move on to the next hole. The last image on the right-hand side, so here we have 2 of the hot dip gulf bolts installed, and you'll notice around the edge there's like a metal bracketry, and this was to tie in and restrict the grout when that went in. So the bolts went in first, and then the grout went in. What grout was used? Well, this was an SBD product, the Epoxy Plus. So the idea was, again, you've got to remember this was probably March, April time, so potentially the weather could be a little bit inclement. So catering for this sort of situation. The guys had the marquee that was quite manoeuvrable along the track, so where they were working, if it was required, it could simply just be slid over the top. This was either as part of the installation process when they're assembling the grout pads, or maybe whilst it's curing. So the next images show the grout being installed. So we have that chute on the left-hand side. So the grout was mixed up and simply poured in through that chute, and then gravity took effect and it would travel under the base plate, but it was obviously contained within that shroud. Now the middle image shows some quite high-tech stuff here. We have plasticine on the top. So once the level had been reached, plasticine went on the top, and also around the edge to prevent any leakage, sand was also deployed. So the image on the right-hand side is a finished grout pad, as you can see, and the image at the bottom of the screen shows obviously where the sand had been deployed in the middle. The guys just simply dragged it along the forefoot, and once the grout pads had all gone off and the shutters removed, they simply tidied that up afterwards. Now there's some other bits and pieces of track work that were required. On the S&C, the specification was for a 4-hole base plate, and this was actually the Colin egg. And I must confess, this was the first time I'd come across this, but the designers, that's what they recommended, that's what was going to go in. And as you can quite clearly see, it's a 4-hole plate, but once again, the Hilti RE500 resin was the anchor of choice. The other part of the track work, of course, being DLR, is the third rail. So the third rail was part of the concrete cast segments of the viaducts. A number of plastic sockets internally threaded sockets were cast in these recesses. So it was quite a straightforward job to simply attach the third rail bracketry by spinning in some galvanised bolts into the predetermined holes. And if you notice in that middle image, you notice there's some slots for the hole to pass through. So this allowed a little bit of manoeuvrability if they weren't quite precise in the original lineup. And then the image on the right-hand side shows obviously the conrail attached. And this is standard DLR practice where the conductivity is picked up from the train from the underside of the rail, not the top of the rail. Now, part of our support package with AMEC was we would test a number of anchors on their behalf should they need it. They liked the idea of some anchor testing to go ahead. However, they preferred an external source to do this. So they decided there was something in the region of, I mean, it was something like 30,000 anchors that went in. And they decided that 5% would be tested in pure pull-out in tensile, and an independent company was going to go and do that on their behalf. It was a fairly minimal load that they were testing to, and I can count on one hand, I think it was something like 4 anchors failed out of the hundreds that were tested. And all they done, they simply marked those up, so you can see the images on the right-hand side, and they were removed by unclipping the base plate, sliding it along, and then just simply overcoring, removing, and then reinstating. So this proved, you know, how good the resin was. It's very tolerant of conditions, and the resin itself actually permeates through the concrete, so it provides an excellent bond. So just to sort of plug a couple of gaps, obviously this presentation was severely geared around the track work itself, but I just really wanted to share with you some imagery showing some of the stations being built. So this slide here, you can see there's a fairly consistent model that's used here, and it was replicated on these stations going along the route. We have Silvertown on the left and Pontoon Dock on the right. I'll be honest, I didn't have too much involvement with this. It was more the track work that I had involvement with. So in summary, Here's some details with regard to the components that were used. So as you can see on the image, it was an 80-pound rail, which is standard for DLR. For the plain line, the Viper plate and pan drill, and then the clone egg was used on the S&T. The drilling wagons, along with our T80 percussive drilling machines and their 28mm drill bits. It's also interesting to note with the drill bits, they needed to be slightly longer because the drilling machine was mounted higher up and you would use it being handheld. So we provided longer drill bits as well. And then we have our resin, the RE500. We have the M24 hot dip gal grade 8.8 high tensile bolts that was sourced, I believe, with the base plates as well. And then as you see, the grout was an SBD product, and Bretton Willis, their bracketry was used on the third rail. So that really kind of concludes the presentation, but I just really wanted to show you one more slide, if I may. This slide here, so this gentleman standing up with the glasses facing us is a gentleman called John Saxby. And for those of you that have been here a while, you may have come across John in your tenure within the rail industry. He's retired since, but he was a very good ally on this project. He was very knowledgeable, obviously been on the railway for a number of years. A lot of the work he'd done had been on traditional sleeper track, and he had done some work actually at Waterloo on slab track, and that's where we first met. David McNeil was the chap with his back to the camera. He's the QS. But what was so striking about this photograph, and this project, before we even started drilling holes for the actual track work, this project was probably running for the best part of 9 or 10 months. And I was on site literally every week. And one day I was going over the viaduct at Canning Town, and there was a very dramatic sunset. And I mentioned to John when I see him the following week that, you know, that would make a striking photograph if anyone had been there. And he said, Colin, coincidentally, we had a professional photographer on site that day, and he went out and we set this photograph up, and that's the photograph you see in front of you now. This photograph was also used in the July 2005 edition of the PWI journal. And if any of you got access to that, you'll see it's got that in there. And the photograph was taken by a chap called Robert Bostic. So that really concludes my very brief tutorial overview. So I'll gladly answer any questions if I can drag my memory back that far enough. Is there any questions?
So I'm not seeing anything in the chat at the moment, Colin.
Okay.
But if anybody wants to ask a question out loud or in the chat, please feel free to do so now. Okay, maybe I'll ask one, Colin. Yeah, so the method of inserting an anchor and surrounding it in resin, there's other methods as well I've come across in my time where you would insert like a plastic dowel, put a screw in, and you would set the either set the dowel in resin or in concrete. But have you got any sort of preference for which way or which what gives the best results over a period of time? Have you got any? I appreciate that Hilti have probably been involved in both methods for drilling and setting the anchors in. But
yeah, no, that's an interesting comment, Phil, because this conversation come up with both John and David, and they was looking for some feedback about that very scenario. Why don't we glue in a socket, a plastic sleeve, if you will? In our experience, what we found is the thread on that nylon or plastic socket will fail very quickly if you put a loading tension on it. So we spoke to John and David about that. We give them some honest feedback, and it was decided they would prefer to have a male anchor chemically adhered to the concrete slab. And it was purely down to the load performance. Their concern was the anchor would fail
Yeah. Okay. Okay. Yeah, thanks for that. Any other questions from anybody?
Yeah, sorry, I've got one, Phil or Colin, if it's all right. How long did that take? Because it looks quite a labour-intensive task you're doing. How long was the project in total, and sort of how long did the drilling take as a sort of a percentage of the project, if you like?
Well, if you like, before we even got as far as the trials, there was a lot of testing done up on site, probably 6, 7, 8 months in advance. AMEC had access to site in advance, which certainly helped and enabled various different trials to be undertaken. The actual drilling time, using that as a pillar drill, was less than a minute. It wasn't reinforced concrete. It had like what they call no fines, like stainless steel shards in it. So there was no challenges in hitting reinforcing bar and then having to come along with a diamond drill. So it was sub 1 minute to drill one hole. And when you look at the base plate spacings, I think they were 650s off the top of my head. You know, you could do 4 holes if you got 2 rigs side by side, you know, in a couple of minutes. So I think the concern was if you drilled handheld, the time-wise wouldn't make any real difference, but potentially, you know, the drilled hole wouldn't be perpendicular to the slab. So this way, it reduced halves and it ensured it was perpendicular, and you had the ability to control the depth of hole, which obviously become relevant when you start ejecting the resin using the dosage meter.
Okay. Any more questions? I think that's pretty much it. Colin, I don't think anybody has got anything more they want to ask.
Okay, that's great. Thank you very much.
Okay. Well, Colin, you know, thanks very much. Yeah, it's a very interesting presentation. It must have been about 16 years ago now that was done. So assume it's holding up well, and yeah, I don't know whether you've had any feedback from DLR or anything, but yeah, it looks like an interesting job. And I think the Woolwich extension followed that as well, didn't it?
That's correct, yeah.
Yeah. Okay. Well, okay, Colin. Yeah, thanks very much for stepping in at such short notice, actually, because there was another presentation planned for today, and very quickly stepped into the breach and covered it. So it's really good. So just to say thanks on behalf of everybody listening in, and yeah, if there's anybody else who wants to make any further comment, happy to put the floor over to anybody else.
Thanks for that.